Hello and welcome everyone. In this video, we are going to talk about the round-robin method of scheduling algorithm. So what is round-robin method? Well, in round-robin, CPU runs a process for a given quantum. So when you get a question in the examination, they will give you a quantum, let's say 2. Okay, so the CPU runs a process for a given quantum value, let's say 2 units. And then it puts that process back in the ready queue and runs another process. So as you know, in preemptive scheduling, a process can be interrupted and another process can go ahead and start running. So that's why in round robin, it states that it runs for a given quantum value, let's say 2 units. Then that particular process, let's say process A, goes back in the ready queue, and let's say process B will come and start running. Okay, and the same process is repeated. So how are we going to implement that? Well, we'll create two queues, ready queue and running queue. Then first we bring the process in the ready queue and then move it to the running queue and then run it for the given quantum value, let's say 2 units. Next, after a given quantum value, which is 2 units, we bring other process, for instance, P4 and P3, that have arrived at that time in the ready queue. If previously executed process still has time left, we place that back in the ready queue after the arrived processes, let's say P4 and P3. So let me explain to you how this is going to work. So in the examination, you will be given a question. For instance, it'll say that, okay, you have 5 processes, each having the arrival time and processing time. And go ahead and calculate the completion time, average turnaround time, average waiting time, etc. So in order to solve this, we'll create two queues. One is ready queue and second is running queue. And then we'll start to solve this. So let's see how we can do that. Okay, so let's say that at the time interval 0, okay, in the running queue as well, as we have two queues, ready queue and running queue. So in the ready queue, let's see at time 0 if there is any process that has arrived. So at time 0, we have P1 arrive. So we'll first move that process in the ready queue. Once you move into the ready queue, from here it goes to the running queue. Okay, so we'll go ahead and put the P1 into the running queue. So we'll move that. And how long we are supposed to run it? Let's say that we have been given the quantum value of 2. Okay, which means we are supposed to run each of these processes for 2 units only. Okay, so I would say maximum 2 units. All right, because there could be a scenario where a processing time is only 1. So in that case, we can't run that process for 2 units because the duration is only 1. So maximum 2 is what we want to do. So for P1, we'll run it 2 because its processing time is 3. So it's definitely can be run for 2 units. So we'll run it for 2 units. And once we run it for 2 units, we check at 2 unit of time or at 2 interval of time, are there any processes that have arrived? Yes, we can see that P2 has arrived, right? So if P2 has arrived, then we are going to place that P2 into the ready queue. So P2 goes ahead and moves to the ready queue. All right. And then at that time unit, are there any other processes? No, there isn't. Okay. So since we've already executed P1 for the interval of 2, so what is remaining is 1, correct? Because already executed for 2 units, only 1 is remaining. So once we have brought whatever process had arrived at that point at the interval 2, we're going to put that in the ready queue. And then we also put P1 after that, not before that, because it's not fair to put P1 before P2 because otherwise P1 will continue executing and it doesn't really make sense. We're not really going with the preemptive method then, because if we are allowing all the process, if we are allowing a process to execute fully, then we are not really following preemptive. It will become non-preemptive because it'll get executed till its processing time. So we don't want that. We want preemptive. That's why we'll execute only for 2 units and put that in the queue. So we'll give chance to P2 or other processes to be executed. So in this case, we put P1 over there. Okay, so this one is done. Now, what is next? We have P2, so we bring that in. Okay, So we bring P2, and how long we were supposed to run it? We're supposed to run it for 2 quantum, because that's our quantum unit, which is 2. So that's why we will run it for 2 units. So how much is remaining now? So cancel that. So we have 4 remaining in the P2. Okay. So now at time, this becomes actually 4, not 2, because 2 plus 2 is 4. Okay. So at time interval 4, what do we have? So at time interval 4, we have 1, 2, 3, 3 processes, right? Now P2 is already in the queue, so we can ignore that. What is not there is P3 and P4, because we already have these 2 processes which have arrived. At time interval 4, we already have these 2 processes which have already been arrived. So what we'll do is we'll put that in the same order. So make sure you put whatever comes first. Don't put P4 and P3. It'll be P3 and P4. So we'll put P3 and we'll put P4. Okay. So they go ahead and move over here. So P3 moves here, P4 moves here. They go inside of the ready queue. Okay. And then because P2 still have these 4 units remaining, it will be placed after these. So like we place the P1 after the other process that have arrived, similarly, we'll place the P2, whatever's remaining, after these 2 processes. Okay. So we'll put P2 over here. All right. So what next? Next one, we have P1. So we'll bring that into the running queue. We'll put P1. Now what's remaining time? Remaining time is only 1, right? So there's no need to run it for another 2 units because the remaining is only 1. So it doesn't make sense to run it for 2 units. So we'll run it for 1 unit. So it becomes 5. So remember the rule. We should run it for maximum 2 units, right? So in this case, it satisfies the condition. So we ran that. So P1 is done. So check, P1 is done. This becomes 0. So that's fine. And now at time interval 5, what else do we have? So P3 and P4 are already inside of the ready queue. So we can leave that. P2 is also in the ready queue. So we can leave that as well. Now we have the P5. Okay, so P5 is here. So we can put that in the ready queue. And P1 is already finished its execution. So we don't need to worry about it. We can just leave it like that. We don't have to execute it again. So we don't need to put it in the ready queue because it's finished its execution already. There's nothing left here. Okay. So now next P3 comes in. So we'll bring P3 in and run it for 2 units. But we can't run it for 2 units, right? Because only one, its processing time is only 1. So it actually runs it for 1 unit, not 2. So 5 and then this becomes 6. All right. So then P3 is also done. Nothing is remaining, which is great. Now we come to P4. So we bring P4 in. So P4 comes in. Its execution, its burst time is 4. So we can run it for 2 units as per rule. So 6 plus 2 is 8. 6 plus 2 is 8. So we run it for 2 units. We cancel 2. So remaining is 2. Then because there are no other processes which are already present, everything is here in the ready queue. That is why we can simply place P4 at the end, because we still have the remaining units from the processing time left. It is still supposed to execute. So we're placing it here. If we had any other processes that were not put in the ready queue, then we'll place them first and then place P4. But because we don't have any other processes, all the processes are already there in the ready queue, and some of them are already executed, finished their execution. That's why we can directly place the P4 over here. Okay. So now next, we'll bring P2 in. How long we'll run it for? So P2, we'll run it for another 2. So 2 is remaining. So 8 plus 2 is 10. So we'll run that. Remaining, we'll place it here. Okay. Then P5 comes in. So P5, we run it for 2 units, 2 remaining. P5, that becomes 12. And because there is a remaining 2, we'll put P5 over here. Okay. Then P4 comes into the ready queue, running queue. How long will you run it for? 2 units remaining. So now this becomes 0. This becomes 14. Then we'll bring P2 in. How much remaining? 2. So we'll run for 2 units. P2, this becomes 16. And then finally P5 comes in. How much remaining? 2 units. So now it's all done. So that becomes 18. Okay. So all the processes have finished their execution. Nothing remaining. You can see everything is 0 here. And we've actually created a running queue with proper intervals, right? Now we need to calculate the completion time. So when you think P1 completed, so start taking a look from the end, not from the start, because it might have started to execute and then it got interrupted because we brought another process in. That's why do not check it from the left, but check it from the right. So is there P1 here, P1, P1, P1? Okay, here is the P1. So it completed its execution at time interval 5, right? So we put 5 here. Completion time is 5. When did P2 complete? So let's check it from behind. Here it is, P2 at 16. So we put 16 over here. Similarly, what time P3 completed? So P3, let's check it from behind, from the right hand side, at 6. So we put 6 here. P4, 14. And P5, 18. Okay, so now let's calculate the turnaround time. Turnaround time is CT minus AT, which is completion time minus arrival time. 5 minus 0, 5. 16 minus 2, 14. 6 minus 3, 3. 14 minus 4 is 10. 18 minus 5 is 13. Okay, and then waiting time will be TAT minus PT, which means turnaround time minus processing time. So 5 minus 3. So 5 minus 3 is 2. 14 minus 6 is 8. 3 minus 1, 2. 10 minus 4, 6. 13 minus 4, 9. Okay, so in the examination, it will ask you, please calculate the average turnaround time. So all you have to do is just make a total of this, whatever this total comes in. 5 plus 14 plus 3 plus 10 plus 13, and divide that by number of processes. There are 5 processes. So whatever that value comes in after calculating this, that becomes your average turnaround time. And similarly, you can calculate the average waiting time. So average waiting time becomes 2 plus 8 plus 2 plus 6 plus 9 divided by 5. That becomes your average waiting time. All right. So I hope the round robin scheduling algorithm is clear to you, and I hope you enjoyed it. Thank you very much. Bye-bye.